Welcome back to this lesson. So this is our lesson. We're now in lesson 4 of this agentic AI business solution architect domain 2, which is design AI powered business solutions. And we've been discussing the outlines. We'll be discussing our agentic AI design, our extensibility and orchestration. So if you are just joining us, please kindly like and subscribe and share with others to encourage your girl. Thank you. So our first lesson here is language architecture. So remember, when you're designing, you choose a base model, and your base model are a large language model like ChatGPT, Claude, and Copilot itself, Microsoft 365 Copilot. So language model involves this is used when you are designing a conversation model like a prompt and response agent, any agent that will interact with customers, interact with users in Dynamics 365. So these are language all this we use language architecture. So we have NLU, we have CLU, we have NLP and NLU plus. So let's see how you can design for this. So NLP versus CLU versus generative AI orchestration. So these are requirements for language architecture, and these are the best approach that you can take on the right hand side. So the fixed command, look at the first one, fixed commands. So the fixed commands are standard NLP or CLU for deterministic intent routing. Okay, so fixed commands are standard NLP, natural language processing, or CLU. CLU are are used for deterministic intent routing. Okay, then we have variable phrasing. So these are conversational language understanding and generative AI. So these are the best approach. So if you are designing, if your requirement is variable phrasing, then you should use CLU or generative AI. And if your requirement is fixed command, use standard NLP CLU for deterministic intent routing. Then if you are using RAG or open-ended answer, then you should use the best approach you should take is generative AI orchestration with grounded retrieval. Okay, if you are using summaries and synthesis, then you should use best approach should be generative AI with structured prompts and safety controls. Then if your requirement is deterministic routing, then you should use NLP CLU preferred. Generative AI require guardrails. So deterministic routing, best approach should be NLP and CLU, conversational language understanding, or generative AI that with guardrails should be what you should use. Then your rule of thumb here is use structured approach, use NLP. For variable, requirement, for structured requirement, use NLP. For variable requirement, use CLU, and for reasoning and RAG, use generative AI. So this should be rule of thumb. Have this at the back of your mind. Very, very important. Okay. So very important. So if you are building if any of the requirement that is structured, use NLP. Any of the requirement that involve variable input and output, use CLU, conversational language understanding. Any of the requirement that require deep reasoning and RAG database, then you should use generative AI. Okay, Copilot Studio. So we are here at Copilot Studio again. What do we want to look at here? We want to look at design agent and agent flow in Copilot. So what are the requirements? What are the tools available? Can you put the workflow together? Can you apply task boundary or test it within the Copilot Studio? So I am not on a paid Copilot. If not, we would have done one architecture, but this is not a practical examination. This is theoretical examination. And then, as an architect, you are not going to be developing, you are only designing the solution and giving it to agent builder to build or developers to build. Okay, so you are an architect now, not a developer. So architecture terms that you should understand under Copilot Studio are mission, scope, guardrails, action, and escalation. I believe we'll be discussing most of these terms, so you know the meaning of these terms when we mention it now. So make sure you understand them as your architecture's term. So let's look at our first point here. The first point we have here is define mission, scope, success criteria, user rules, data, tools, and allowed actions. Make sure all these are well defined. Why are you designing the agent in the first place? That is the mission. What is the goal? We've looked at goals, action, and tools in the other parts, but this is still an extension because we are working in Copilot. So design mission. What do you want the agent to perform? What is the goal it should achieve? Define the scope. So this is skills and context boundary. This define success criteria, still the goal that you want to achieve, the output that you want to use to measure the success criteria of the agent. Design user rules. Okay, so user rules are just like give the agent rule and give the user rules. Very, very important. Make sure you define the data that the agent will use, and make sure you define the tools that the agent can call. Also define allowed action. These are actions that the agent can perform. Okay, so all this must be clearly defined. Then separate knowledge retrieval, workflow execution, human escalation, and monitoring responsibilities. Okay, so all this should be separated from each other. So the flow is when you choose base model, then you develop your prompt, system prompt, and user prompt. So these are rules that you should design. Then after that, if that is not enough, then you connect the RAG database. Okay, so after RAG database, you can now start fine tuning where escalation is needed, where you should add workflow execution, where the agent should escalate for human for approval for tasks it should never performed, and where monitoring responsibility should come in. Make sure all of these are separated and not combined together. Then apply task boundaries. Okay, so make sure tasks are not combined. So, and that is why in advanced agentic system development in Azure AI Foundry, we said we should give always make sure when an action is broken into tasks, and make sure one agent handle one task. Do not give one agent multiple tasks to perform. That will reduce the quality of the output of the agent. So let tasks have a particular task ID so that you can map them and correlate them using correlation ID to a particular agent. Agents will also have their identity and names, just like tools have their names and their function and description. Okay, so apply task boundary, apply source constraints, apply fallback path, and apply govern connectors. Very, very important. Choose task boundary. So know when a task should stop and another task should start. Define source constraints, make sure source are bounded, make sure role-based access control is implemented, and agent access only the data it needs, not the entire company information. Make sure fallback paths are properly defined. This is when the agent does not have sufficient knowledge or information to perform the task, then it should fall back to either escalate to human or to stop answering or to route the, whatever the task to another agent or to another part entirely that will continue the operation, and govern connectors. So all connectors should be governed, like your MCP server, your API, your workflow, everything should be governed and set guard and implement under guardrails. So test with realistic prompts. So very, very important. Make sure you give agent realistic prompts. We've spoken about prompts in the slide, maybe in domain 1, where we define the element of a good prompt, and it should be structured. It should have a goal. It should be, contain whether zero shot or few shot. It should be rule based and so on and so forth. So you know how to design prompts. So make sure your prompts are realistic, designed for edge cases where you want the agent to connect to external system, designed for multi-turn conversation where the agent to think in loop and reason and act and reason again in loop until it will answer the question, and then make sure everything still operate within policy guardrail. All right, so we have Foundry models. So you can see everything we discussed under Copilot model. Now let's look at Foundry model. what are the architecture terms that you should understand under Foundry model? So look at the term here. We have model catalog in Foundry. Okay, so model catalog is the catalog of model where you have all the models that are available on Azure platform. You have GPT-4.0, you have GPT-5, 5.5, 5.6, you have Claude IQ, Claude Sonnet, Claude Opus. I don't know whether Fabus is there yet. You have Grok, you have K3, you have Chrome, you have Copilot itself. You have a lot of agents. More than 10 of them there. Plenty variety that you can choose from based on your requirement, based on what you want to spend, and based on the complexity or simplicity of the task or the action that you want to perform. So you have model catalog, you have fine-tuning platform where you can fine-tune prompts, fine-tune the agent, and make the using company data to reduce the complexity of the agent. Then you have responsible AI application. Even in Copilot, you have all the fairness, accountability, responsibility. You have all the pillars of responsible AI, even in Azure Foundry. Then you have observability, where you can collect telemetry data to measure the performance, to measure the token usage and your cost optimization to collect traces of the agent and to collect latency, speed, groundedness and accuracy of the output of the agent. Then you have domain model. So you also have domain model or custom model that are already built there that you can just deploy and fine tune. So custom model in boundary. So this let's go through the point we have here. So use custom model when business requirement exceeds standard Copilot or RAG capabilities. We've talked about this many times. So start with Microsoft 365. Then when it's complex, go to Copilot Studio. If the custom model cannot be deployed or built in Copilot Studio, then you should come to Foundry. So when you need complex custom model with RAG capability or with RAG agent with RAG capability, then you should build in Microsoft Foundry. The strong fit include, so these are kind of agents that you should build in Foundry. Okay, the first one is legal agent. We have healthcare agent, finance agent, engineering agent, strict compliance agent, and specialized workflow agent. So all this should be built in Microsoft Foundry because they are custom and they must be grounded in company knowledge, which is where in all of them be involved using company knowledge as a knowledge base, and that is where RAG capability comes in. So all these agents are multi-agent system, and they should build in Microsoft Foundry. So architecture includes model catalog, training and fine-tuning pipelines, agent integration, responsible AI controls, deployment, and observability. So these are architecture, and this is, you can see them in the architecture terms here. And then we have validate data requirement, evaluation, metrics, risks, and integration with enterprise system. So when you are done building, you are still going to deploy it to and integrate with enterprise system. So you can test in using the Microsoft Foundry Playground. Okay, the playground with there where you can check, and then you can, even from Foundry there, you can collect evaluation metrics to evaluate the performance of the model, and then you can implement risk mitigation there by implementing guardrail, defining policy boundary for the agent, role-based access control, and then integration. So you can also integrate, publish the agent and integrate with enterprise system, Dynamics 365 and Office 365. So then here we have, the next thing we have is Microsoft 365. So design agent in Microsoft 365 Copilot. We've looked at Copilot Studio. We've looked at Microsoft Foundry design pattern. We've looked now let's look at Microsoft 365 Copilot. This is the simplest of them, where you can just build personalized agent for simple tasks that you use that you normally perform day to day and that are repetitive and follow the same pattern. So the architecture terms that you should understand here is Microsoft Graph. Very, very important. All these architecture terms we are discussing is part of the examination. Okay, so Microsoft Graph You should understand Microsoft Graph because that is how agent that you build in Copilot integrate with other Office 365 application. So SharePoint is one of the term is the knowledge base that you can easily connect Copilot agent with. We have Teams, okay, agent that you build in 365 Copilot can easily be integrated into Teams. We have OneDrive and we have Agent Builder. Okay, so these are terms that you should understand here, and most of them, trust me, SharePoint is in the examination, Microsoft Graph is in the examination, Agent Builder is part of the examination. Okay, so a Copilot agent automate tasks, retrieve information, summarize content, and execute workflow. We've talked about this before. Any text that is repetitive, that is personalized, and that follows the same pattern, you can easily build them in Copilot, Office 365 Copilot platform. So design begins with business objective. Before you design, have the purpose. What do you want the agent to do? What is your objective? What is the business objective? Which problem, which pain point do you want to use the agent to solve? Very, very important that you design the objective. Okay, design the required decisions, require systems, roles, capability, guardrails, escalation rules. Okay, so even though you are connecting the agent to a platform like SharePoint, make sure that you still give guardrail. Okay, it is not all your information that on SharePoint you should connect the agent with. It is not all your information on OneDrive you should connect the agent with. So make sure the particular files that you want the agent to access, you put them in a folder, and then you limit the access of the agent to that folder, not your entire SharePoint folder. So it's very, very important that design business objective, required action that the agent should perform, require system it can connect to, the role of the agent in your system prompt design, clearly define it, clearly define the capabilities also in the system prompt, and the guardrail, role-based access control list, privilege, and escalation rules, where the agent should call a human if it cannot summarize or if it doesn't understand any information that it is being given. Point 3, connect data and tools through Microsoft Graph, SharePoint, Teams, OneDrive, API, and Enterprise Connector. Believe me sincerely, this statement is in the examination. Okay, we ask how you can connect data to SharePoint. Okay, what tools can you use to connect data to Microsoft 365 Copilot agent? And one of the options there is Microsoft Graph. So the answer is Microsoft Graph. Believe me sincerely, questions on SharePoint are about 3 in the examination. So this particular sentence is just like an expo for you if you are writing the examination. So connect data and tools through Microsoft Graph, SharePoint, Teams, OneDrive, APIs, and enterprise connectors. And then the last point we have here is collaborative patterns include sequential, parallel, feedback loop, and orchestrated agent. So collaborative pattern are, how the agent can interact with other tools or with human being that is using it. So the action pattern of collaboration can be sequential, can be parallel, it can be feedback loop. So where it just operate, it's racing out and then racing again, it's racing out, observe, and then racing again in that loop until it performs the task, and then through orchestrated agents. Maybe you can also combine one or more agents through an orchestration where the orchestrator agent will coordinate other agents. So this is how you can design in Copilot or Office 365 Copilot and the architecture term that you should understand. Okay, so we have Copilot Studio extensibility. So extensible agent layers. How can you extend the capability of the layers in Copilot Studio to other roles? So we have the first one here, instruction level. So the design rule for instruction level is purpose, tone, constraint, escalation, data boundaries. So instruction level, so when you are giving instruction, make sure the instruction is purposeful, make sure the tone is grounded in company information, grounded in compliance, make sure you implement constraint by giving the agent boundary that you must never cross, escalation. So make sure the agent has the option to escalate to human and define data boundaries. Okay, define data that you can access and the ones you must never access. Then skill level. So also make sure another layer is skill level. So the design rule you should understand here is enterprise knowledge. So the skill the agent should use, any agent in Copilot Studio or any agent Action should use is enterprise knowledge. And within the enterprise knowledge, limit the skill level to particular domain. Okay. So limit the skill level to domain, make the skill level domain based in the enterprise knowledge base. So API actions are part of skill level, multi-step workflow are part of the design that you should implement a skill level. Integration level. So in integration level, you should understand the design rule. Dynamic 365, you are building an agent that can be integrated with Dynamic 365, can be integrated into databases, okay, for query and visualization analysis, data analysis, and calculation and generation of visualization. Can be integrated with Power Automate as part of the workflow, and it can also be integrated with external API. Then we have Pro Code extensibility. So another layer of Copilot Studio extension, another layer where you can extend Copilot Studio to is a Pro Code or code area. So you can extend it to Visual Studio Code. Okay, you can extend it to other custom logic platform, Visual Studio like GitHub and reusable components and advanced orchestration. So these are also this design rule or extension layer. Then we have patterns. So the pattern layers. So let the agentic AI pattern be modular. Let it be multi-agent where multi-agent is required, and let it operate within the domain context agent. So make agent design agent for domain, not entire platform. So when you design agent that are domain context, then you will operate within the domain boundary because you are designing agent for a particular people. You are not combining the whole organization into one task. No, design agent for particular business domain and put the domain context into practice. Limit agents to particular domain when you are designing, so that you can have a maximum output and quality answers and output from the agent as well. It's very, very important that you understand this extensible agent layer. So we are done with this part of the lesson. If you are just joining us, please kindly like and subscribe so you can get our next video. Thank you.